Alright, hey everybody. So hopefully the sound works this time, and so we're talking today about refraction of light. So if you remember from my previous video, refraction is whenever light enters in from one medium to another, like from air to glass. And when it does, it changes direction. You might remember that arrow I had behind the cup of water. It was pointing one way when you had no water in the cup, and then it flipped around the other way when you put water in the cup, because water and air are two different media, and as a result they have different densities. One's more dense than the other. So when light goes through something that's more dense, it tends to slow down, and as a result it changes direction. Same thing the opposite direction, when you go from something that's more dense to less dense. The change in density causes a change in direction. So let's look at that for a second. So, excuse me, we'll start with picking up a magic marker here. There we go. Alright, so if you look over here on the left, you'll see in this we go from air to air. When you send a beam of light from one air medium to another, as long as they're both the same type of gas, right, there will be no change in that object's line. It will go straight through with no issues. Now, if, however, you go from something like let's say air into something like glass, well, glass is a solid. It's more dense. As a result, light's going to go through it slower. All right, there's a change in speed when you change medium. So when you go from air to glass, when this light ray comes in, we call it the incident light because it's what happened, right? What was the incident? What happened? So it's kind of beginning here with the incident light coming in, and then it hits this line here. It's not a real line necessarily, but it's just the marking between the air and the glass. When it hits that barrier between the two, it has a change in direction. But the change in direction we often make relative to something called a normal line. In math terms, a normal line is simply a line that forms a right angle. All right, so it forms a perpendicular line to something we're talking about. So in this case, we're talking about this demarcation line, right? And the normal line forms a right angle with it, a perpendicular line to it. Okay? Now, as the incident light comes in, it goes from air to glass. As a result, it slows down. And in this case, it will move slightly towards the normal. All right? So this is the normal line. You see the dotted line all the way down here. So when you go from something less dense to something more dense, your line of light will typically move towards the normal line. All right? You can see the original path is supposed to be this direction, but it has moved over. It's moved towards the normal, okay, towards this center line, all right, which we, again, have just drawn with a little dotted line to show it's not real, it's imaginary, but it's moving towards that normal line. On the opposite end, you can go from something like glass to air. In this case, you're going from something that's more dense, right, to something that is less dense. And so whenever you go from more to less, you're going to do the opposite. Instead of bending towards the normal, like they did over here, you're going to bend away from the normal. So let's look. We got the incident light coming in, and it should go straight through in the same line. But since you go from more dense to less dense, it's going to move away from this normal line. So it moves out. All right? You might remember this from our song. So it says something along the lines of moving to the normal when it's getting thick. When the medium goes from over here, again, from air to glass, all right, it's getting more thick, more dense. As a result, it's moving to the normal when it's getting thick. The original line should go this way, and instead it moves towards the normal. Okay? Over here, we're getting less dense. That means thinner. And in this situation, instead of moving towards the normal line, we move away from the normal line. And you end up with the refracted ray pushing away. Okay, and this is because the light can actually speed up. It's going slow through the dense glass, right? And then it goes fast through the air, and as a result, moves away from the normal line. This is just the way light behaves. And it all matters, it all depends on whether or not it's a change in the medium. If it's the same medium, no change. If there is a slight change in the medium there, then you will have a slight change in the direction. This is most often best represented, I think. Actually, do I have a picture of it on here somewhere? I might not. I don't think that I do. Okay, let me pull up an example of what I want to show you here. Alright, let me see. We'll do, That's probably not a good one. There we go. Okay. So this is best exemplified with the following image. So you guys have all probably seen this driving around Georgia in the summer. And one of the things you'll notice here is that it often looks like there's water on the road when there's actually not. All right. So in this case, as you drive up closer, you notice that, hey, well, the water's disappearing. Well, the water's not disappearing. The water never existed. All right. This is actually the result of refraction. So what happens is the asphalt is black, so it heats up. It absorbs a lot of heat really quickly. And as a result, the air really close to the surface is very, very hot. All right? And when something's very, very hot, it tends to spread out. And that's what you got here. You've got less dense air down here next to the road. All right? And you have more dense air up here. I don't think I can click enough of those to do it. So we'll just say it's more dense up here. All right. So as a result, light will travel from a more dense to a less dense medium. All right. And when it does get down here to the less dense medium, it changes direction and comes to you. So essentially what you're looking at here is you're looking at the sky. This stuff you see, the actual like water on the road that it looks like to me, it's actually just the sky, the refraction of light off of the surface. Because it's changing direction so much, it's actually acting like a mirror. It's bouncing off, and to your eye appears to be a little bit of water. This is often the case in the desert. You might have heard of an oasis. Like people in the desert who are dying of thirst, they see an oasis of water. You know what I mean? They look like, oh, there's some water, and they go walking towards it into the desert, and they die. They die because they don't realize they're not looking at water. They're looking at a reflection of the sky, or I should say refraction of the sky, caused by the sand overheating. In this case, caused by the asphalt overheating. This only happens in the summer when the asphalt gets really hot, and you get a big difference in density. Again, everything here is about density, the density of the medium. But here's the thing, both of these are gases. In this case, the change in density is caused by the change in temperature. Things that are hotter spread out more. Things that are colder are closer together and more dense. So that causes the change in medium and thereby the refraction. So you see a little bit of reflection even of that car up ahead. Pretty cool. So anyways, that's all there really is to it.